Hello everyone, I am Dr. Siraj Faisi. I welcome you in my YouTube channel. Today in this video I am going to talk about carbohydrate and I hope this video will be beneficial for you. So let us start. Carbohydrates. Friends, the term carbohydrate was proposed by Smith in 1844, CnH2nM, where N is equal to 3 to 9. A carbohydrate is macromolecules consisting of carbon, hydrogen and oxygen atoms, usually with a hydrogen-oxygen atom ratio of 2:1 as in water, with the empirical formula CmH2n. Structurally, they are polyhydroxyaldehyde and ketones. So, friends, now carbohydrate classification. There are two classes of carbohydrates: simple carbohydrate and complex carbohydrate. Simple carbohydrates are monosaccharides. Spelling wrong here. Monosaccharide, two or more monosaccharide linked together. Disaccharide linked to monosaccharide. Oligosaccharide 3 to 10 monosaccharide, and polysaccharide have 10 or more. So homopolysaccharide and heteropolysaccharide, it consists of same monosaccharide residue, starch cellulose. Heteropolysaccharide of different monosaccharide residue, hydroic acid. So monosaccharide classifications: type of carbonyl group, ketose or aldoses. You can see D-peroxo, D-ribose, ketohexose and aldopentose. On the basis of carbon, 3 carbon trioses, 4 carbon tetroses, 5 carbon pentoses and 6 carbon hexoses. Now number of optical isomer 2 to the power n. You can see Dexter reference compound diglyceraldehyde. This. So carbonyl and hydroxyl group of monosaccharide react to form intramolecular hemiacetal. This is the intramolecular hemiacetal. The structure of monosaccharide is presented in 3 forms: Fischer projection, straight chain representation, Haworth projection, simple ring respective, conformation represent chair and board configuration. So structure of monosaccharide: Fischer projection. You can see the beta hemiacetal hydroxyl anomeric center, this center. This is an alpha hemiacetal hydroxyl. So D-glucose, Dexter here is so this one is beta D-glucopyranose and alpha D-glucopyranose. So friend, hydroxyl group at the aromatic center is called hemiacetal or glycoside. Diastereomers that are not mirror images of each other. Anomers, diastereomers differ in configuration of the anomeric carbon atom, and at the location of alpha enomer, hemiacetal hydroxyl is the same as in chiral center hydroxyl. Now friend, characteristic tautomer is ring chain on cyclooxytautomerism. So friends, I hope you will understand. You get it very easily. Prospective Haworth, this is the Haworth and this is the Haworth from conversion from here to here alpha D. So beta is how you convert Fischer to Haworth. Now mutual rotation is the change in a specific rotation that occurs when alpha or beta of carbohydrate is converted into a mixture of the two. Isomeric transformation of monosaccharide by the action of alkalis is called epimerization. And what is the epimer? Epimer are called diastereomers that are differed by configuration of only one of several chiral center, D-glucose and D-mannose and D-xylose and D-ribose. So epimerization in alkaline medium -I -M keto in all tautomerisms happen here. Then D-mannose, D-fructose. You see the intramolecular pentose, it gives furfuran, but hexose, it gives 5-hydroxy methyl furfuran. So reaction to distinct pentoses to hexoses. And pentose gave furfural, and this one molystes in naphthol in sulfuric acid, it gave this product, red violet condensation products. So cell B0 test, you can see 5-hydroxymethyl furfural react with isorenol, it gives cherry red condensed product. So reaction involve aldehyde reaction with hydroxylamine, you see oximes formations. Cyanohydrin synthesis, you can see CN and then hydroxy acid and then lactone cyclic, and you can see reductions, diabetic sweetener sorbitol, this is the sorbitol. Now oxidations, you can see the D-glucose, D-glucoric acid, oxidation by enzymes. Now identify the aldehyde groups with tolerance reagent, failing solutions. Glycosides formations, you can see this is the alpha and this one is beta. Now acetylations, or OH replaced by OC, and then alkylations, or H replaced by methyl. Now disaccharide may be reducing or non-reducing. In reducing disaccharide, glycoside bond is formed by the hemiacetal glycoside hydroxyl group and one alcoholic hydroxyl group usually at carbon 4 of another monosaccharide. Thus there is one free hemiacetal hydroxyl group. So in non-reducing disaccharide there is the absence free hemiacetal hydroxide. So maltose, you can see this is the reducing, non-reducing. This is the structure of lactose. You can see the structure of sucrose, alpha beta 1 to glycosidic bond is bond, non-reducing sugar. Inversion, a sign change of a specific rotation after hydrolysis of sucrose. A mixture of equal amounts of D-glucose and D-fructose is involved sugar. So doesn't mutarotate, no silver, no reactions, sucrose properties. Hydrolyzing to glucose and fructose, alkylation to ether, acylation to ester. So you can see the starch, dextrine, maltose and D-glucose. You can see the amylose, iodine, amylopectin, heteropolysaccharides, sulfate, heparin. So friends, I hope this video will be helpful to you. If you like this video, then subscribe.